Good morning, everybody. Welcome to Margin of Error Day 2. So we have problems 3 to 11 in this packet. I'm going to work through the odd, and then you, I hope, will be successful in completing the even. Now, I mentioned this very briefly yesterday, but I'm going to go into it more today. When you have margin of error and simulations are computer generated. And to see if your data is good, you want to see if your actual data fits within the margin of error of the simulated. So that's going to be a lot of the focus on some of these problems, and that's what you are going to look at. And you'll see that as we go through, probably by problem number 5, or problem number 7, these all start to become problems that came right off the Regents and no longer problems that I found, in the curriculum and in other places. So, all right, let's start with number 3. Decide if the following statement is true or false. Explain your reasoning. The smaller the sample size, the smaller the margin of error. Well, you know what? That is absolutely false. The larger your sample size, the smaller the margin of error, because the larger you go, the more closely your data will resemble the entire population. So you would want your data to be good, and your data needs to be really showing what the population would do given the situation you're looking at. So you would want a larger number, and that would then give you a smaller margin of error. If the margin of error is 0.05 and the observed proportion of red chips is 0.35, then the true population proportion is likely to fall between 0.4 and 0.5. No, this is false. See, what they're doing is they're saying that the 0.05 is a standard deviation. No, it's not, because the standard deviation from our notes yesterday says you double that, and that would be 0.1. This margin of error, the standard deviation was already doubled. So if this is the margin of error, what this is saying is that we've already doubled this, and if I were to subtract this from 0.35, I would get 0.30, and then that would be, let's see, where are my sticks? Here they are. All right, and so then that would be, if I'm writing this as an interval, less than or equal to the proportion, which was my 0.35, which now would be less than or equal to 0.35 plus 0.05, and then that would give me 0.40. So this would have been the higher end. So my margin of error would have been, since they gave me that my P is 0.35, and margin of error is you add or subtract the 0.05. And so again, if I subtract the 0.05 from 0.35, this would be the low end of my confidence interval, and then adding this would be the high end. So that there we would definitely want to say that this interval would be false. So hopefully that makes sense, and you're going to try number 4 yourself. Let's take a look at number 5 and see what's going on here. It says a newspaper in a large city asked 500 women the following question: do you use organic food products? 280 women answered yes. Compute the margin of error and interpret the results in the context. So this is very, very common on a state assessment. They want you to answer the question in the context of the problem. So you absolutely would have to use the wording in the problem when you state your answer in sentence form. So let's first start here. They say that the probability of buying organic food would look like, so the probability of organic would be that 500, nope, I'm sorry, I'm reading the wrong problem. That would be 280 out of 500 people answered. So they asked 500 people, but only 280 answered. So I'm going to use the math so I can write this neatly. And that gave me 280 out of the 500. Said yes, they do. And if I were to divide this on my calculator, because you know we like the decimals here, one of the few places I'm telling you, please give me a decimal. All right, so 0.56 of the people said yes, they buy organic food. Now, because that's what you get for your population proportion, now we have to figure out the margin of error. So the margin of error now, if this is organic, now we want to say, what's the probability of not organic? And I just have to, there we go, not organic. And that's when you say 1 minus your 0.56. And that would be, oh, I'm still under the bar. Okay, let me just make sure, click out of the bar. All right. Pretend that bar is not over the 1 minus 0.56. Sorry about that. And that gives me 0.44. So these two things are important. All right. So I have organic, the people that said yes, 0.56, and then the not organic was 0.44. So now if I am going to find my margin of error now, so now I have my margin of error is equal to, now this is when I would have the plus minus two times the square root of, inside from our formula from yesterday, our P, which is 0.56, times, make this bigger, there we go. All right, times our not P, which would be the 0.44, and this would all be over the N, and the N was the 500 people that they spoke to. So I'm going, you know, order of operations matters greatly, so please take your time on your calculator. You have to multiply the 0.56 and the 0.44, hit enter, divide it by 500, hit enter, then second and radical, and put that answer in, hit enter, and then times it by 2. So this would now equal positive, negative, 0.044. So now that is my margin of error. My standard deviation was actually 0.022, but the margin of error is 2 standard deviations, so 0.044. And if that's my margin of error, and the problem now says, compute the margin of error, which I did. So here's my margin of error. That's the answer to the first part. But then it says, interpret the resulting interval in context. So now that is when I now need a separate question. Now, you guys aren't taking the Regents this year because they canceled it, which I don't know how you feel about that, if that's a good thing or a bad thing. But if this were a question on the Regents, which they do give you, that period means so much because this was the answer to the first part. And now interpreting context means you would need to give me this next sentence. The margin of error of women who eat organic food is, and now this is when I'm using my calculator, and I take my 0.56 and I subtract 0.044, and I get 0.516 is less than or equal to my population proportion P, who's less than or equal to, and now I take my 0.56 and I add 0.044, and that gives me 0.604. Okay, why did that not type in? 0. Okay, for some reason my computer has decided to stop typing. Let's see if I can get it to work again. All right. There we go. 0.604. Nope, stopped working again. Not a good thing. Okay. All right, so the internet's really been giving me a hard time, and I do apologize. It just seems like everybody and their brother now is on the internet, and hopefully this won't happen anymore today. But so this would be the two answers you would give me. And so now I think 4 and 6 are pretty close to these. Let's take a look at number 7. Number 7, next page. All right. So number 7 says, a newspaper in New York took a random sample of 500 registered voters from New York City and found that 300 favor candidate A for governor. A second newspaper polled 1,000 registered voters in upstate New York and found out that 550 people favored this particular governor. So explain how you would interpret these results. Well, we have to first look at the New York City people voting for this candidate, and then look at how the upstate people looked at this candidate. So let's start with New York City. So in New York City voters, we had the probability of picking this candidate was 300 out of 500. So that then gave me this. $300 out of 500 people chose this candidate, said this is the guy they're going to vote for, so that gives me 0.60. And so then if we then come and say, okay, well, if in New York City the probability of that candidate is 0.60, then the probability of not that candidate would be equal to 0.40. So you have those that pick the candidate and those who don't pick the candidate. And then what we want to do is we want to calculate the margin of error for this. And let's just give myself some room here. So now if I want the margin of error for this, margin of error is going to equal, again, plus or minus 2 times the square root of, we had 0.6 times 0.4 divided by the number of people that they spoke to, which in New York City was 500. And again, we take our time, we type that in, super careful, and we find that the margin of error in New York City is 0.44. So if that's my margin of error, my confidence interval, and I always want to, take my time and write my confidence interval, my 95% confidence interval, just because then I might better be able to read the numbers. So now my confidence interval for New York City becomes 0.56 is less than or equal to the population that they just talked to, population proportion, and 0.64. All right, so there's my 95% confidence interval, and there's my margin of error for New York City. Now let's take a look at what went on in upstate New York. So if I'm over here, upstate New York, so the voters said the probability of this candidate would be equal to 550 out of 1,000 would give me 0.55, but let's write that out now. This would now be 550 over 1,000 is going to give me 0.55 who want this candidate. So again, once we know how many want the candidate, now we have to say, okay, what's the probability of people who do not want the candidate? And that would be, 1 minus 0.55, and that would be 0.45. So now, again, I have to go back to my margin of error. And let's do that. So now the margin of error for upstate New York is equal to plus or minus 2 times the square root of standard deviation, and the standard deviation comes from my population proportion, my 0.55, multiplied by who did not want this, 0.45, and now this is getting divided by the 1,000 people that they talked to upstate New York, and that now gives me a margin of error, son of a gun. You can only use the mouse. You hit anything other than the mouse and it just completely gets rid of everything. Sorry about that. Margin of error, let me do this one as fast as I can. All right, so here I am. Sorry about that. Now we have 0.032. So you'll notice we have a smaller margin of error upstate New York, but that would be because we actually talk to a lot more people in upstate New York. So now what we have to do is we have to find the margin of the 95% confidence interval from this margin of error. So the confidence interval now would be 0.52 is less than or equal to the upstate population proportion, and that would be 0.58. So now, here are my two confidence intervals. And they want to know, explain how you would interpret these results. Well, now that I'm looking at these two 95% confidence intervals, one of the things that I notice is there's a really big overlap. You can almost, if we just actually put them next to one another. So this guy here is New York City. So here's my New York City 95% confidence interval. And then if I go upstate New York, here's my upstate New York. You can see that this is a little bit smaller, so it's fitting inside almost all the way. This is a little bit lower, but for the most part, they're overlapping each other. And if they're overlapping each other, you really cannot say that the people upstate are differing in their mindset than the people of New York City. It looks like they're kind of together on this. So what I would say is, how would I interpret this? I would write that because the margin of errors overlap, you cannot say that the New York City voters and the upstate differ. And that would be the end of it. You couldn't see that there's a big difference. And hopefully that made sense. So let's just make that fit. All right. So now let's move on to number 9. Let's take a look at number 9. Now, number 8, you'll notice here's a part 1. This one was right off the Regents. And again, this is when they give you the simulation. So you want to make sure you look at what they tell you, and they want you to kind of come up with the margin of error. So read carefully, circle the important things, and see how you do with number 8. Number 9 now. Okay, here's another one that was on the Regents. I have to say, when this one was on the Regents, the kids like completely melted down. They did not like this one. And it's because it was so wordy, and there was so much to look at. And I have to say, I completely agreed with them. So it's one of the reasons why I think, let me do the odd with the kids and not the even. Let me see, is this locked in place? Okay, it is. All right. So Gabriel performed an experiment to see if planting 13 tomato plants in plastic black mulch leads to larger tomatoes than if 13 plants are planted without mulch. He observed. So this is kind of like the classwork where we used organic and synthetic fertilizer. So this is kind of like a play on that problem, which happened to be in the state curriculum. So yesterday's classwork problem I pulled from the curriculum, and you can tell that the one year when they wrote this Regents, they pulled the same problem. All right, he observed that the average weight of the tomato plants grown in the plastic black mulch was 5 ounces greater. So let's just highlight a little bit here. Let's go here. Was 5 ounces greater than those without the mulch. So grown in plastic black mulch, 5 ounces greater. All right. To determine the observed difference is statistically significant. All right. So again, just like in the classwork, we're going to look at now the difference in the means. And we're going to use, this is the simulated, this is what the computer did. It generates things. And then we would be looking at the actual. So this is a simulation that they did 100 times on a computer. All right. So a computer, this is theory, all theory. And this was actual. This is what he actually did. And so his actual 5 ounce difference is right here, halfway between the 0 and the 10. So I would say this looks to be about the middle. Wait, what happened to my, there we go. So this looks to be where my 5 ounces. So again, this is actual, and I'm going to type that because I just do not want to keep trying to write with this. So this is actual. This is what he actually got, and we are now going to compare this to the simulation, so actual simulation. And they want to say, given these results, what is an appropriate inference that can be drawn? Well, you kind of look at this, and you can see that here you're skewed a little. You're skewed a little on the left, meaning that the difference was quite a lot. And here, kind of the same, 20 to negative 20. Well, actually, no. I'm looking at my 5 ounces. From the computer simulation, let me go to the pen. From the computer simulation, we are kind of normal. I gotta say, I mean, not completely normal, but we're kind of normal because here's the center, and the center was the highest. And we're pretty close to the center. We're pretty close to where the mean would be, or the z-score is 0. And they didn't give us z-scores, but they did, kind of if you have 10 and negative 10, like maybe kind of think about that as being like, one standard deviation and then two, we are really close to the mean. And if we're really close to the mean, we would have to say that there was an observed effect because we weren't, completely dead on. There was an observed effect. We were up a little bit, but it could just be due to the random sampling. So there was an effect, no effect, we would have all been at like 5%. 5 ounces. But there was an effect, and it wasn't really a big effect. So we can't say that the black mulch was better, and we can't say that there's strong support for without. If there would have been strong support, we would have been in the induced range. We would have been in the plausible to the induced range, but we're not. We're in the likely range. So there was a small difference, but it wasn't so great that we would be super concerned. Did I think this was a good question on the Regents? Absolutely not, because I think it required people to have such a deep understanding, and I don't think they gave us enough time to teach you that deep understanding or to let it completely sink in. There was a large outcry from this problem. They never gave one that was this, required this much overall thinking. From there on out, they kind of gave you ones where you could put the numbers in and then you could work with it, and that was so much better, I have to say. I was not happy with this problem. So this one here was one that came after the one above from the state, and this one, they're giving you actual numbers. So here's what she actually did, and then here's the simulation, and you would compare your actual to the simulation and see if it fits in your 95% confidence interval or if it doesn't. So that's a little help for when you get to number 10. This number 11 was at the end of the Regent, so it was worth quite a bit of points. And again, it's going to give you what actually happened, and then here's the computer simulation. And so let's see. So here's the simulation. Why are these things not working the first time? So here's the computer simulation. And they based it on the premise that 60% of the students would prefer a DJ. And they give you then their actual mean, and they give you the standard deviation. So that was kind of nice. You did not have to do anything other than say, okay, let me take my standard deviation and let me double it. Because remember, your margin of error is plus or minus 2 standard deviations. Margin. So the margin of error for this simulation would be your 0.602 plus or minus now, if you double 0.066, you're going to get 0.132. So you're going to get 0.132. So now, if we take this 0.602 and we subtract 0.132, so let's just show you all this that I'm doing. So if I take my 0.602, now when I subtract my 0.132, this is the low end of my 95% confidence interval. So this would be my 0.470, less than or equal to the population proportion, and then I have to take my 0.602, and I have to add 0.132, and it gives me 0.734. So now they tell me to use, when I look down here, they're now telling me, make sure I round to the nearest hundredth. So guess what? This is where I really have a problem with the state. If I did all this work right, they're going to take off a point because now they decide, okay, I did it right up here, but now I have to round down here. So annoying. But anyway, let's just write it out. So now I would have to write it very clearly, no zero. So I don't lose that stupid point. And then this would round to 0.73. And you might say to yourself, they're really almost trying to set you up for a mistake because they're giving you thousandths. You do the work correctly, and then they decide, go to hundredths. Anyway, here is your 95% confidence interval. So this was all the simulated. Now let's go back to the problem, and we have to go back and what was the actual. So the actual said 55 students attending the prom were randomly selected to participate in a survey about music choice for the prom. 60% responded that they would have preferred a DJ over a band. Okay, so now here's the actual 60%. So this is my actual. So this was on part 3. It was 4 points. It actually was not a bad problem, but you did have to know your business. Like if you went into this Regents and you didn't know the margin of error and the confidence interval, and then remind yourself that if I'm going to answer this question, I have to see, do the actual people on the street match the simulation or fit inside, then I wouldn't be able to answer this question. So people either this year seem to get all 4 points or get no points. This was worth 2 of the points, believe it or not. And then here, it's taking your actual for here, your 0.6 in reality absolutely fits in between the 0.47 and the 0.73. So now explain, all right, so the members of the committee vote are concerned, and it might produce a 50-50 split, and you got 60% saying, but here's the concern, would it cause a 50-50 split? And you would then want to say, yes, they are right to be concerned because both the 50% and the actual 60% are both well within the margin of error. So it is likely to happen. So that's basically, whoops, I spelled concerned wrong when I'm typing, not looking. Let's fix that. Concerned, there we go. All right, so that's what, so again, if you knew your business, if you knew the margin of error and you understood what it was talking about in context of, here's what the simulation says you should have, here's what you have, compare the two, you said, whoa, this was a great, 4-point problem. If you weren't, too strong with this, then this was one of the ones that, people really just struggled with. So again, we don't have a Regents, but you are going to have a test and a quiz on Friday. So today, please do the even problems, do the 4 through 8, so not too many. So it does give you time, because I know that these problems take a lot of thought. So good luck, and let me know if there's any troubles that you're having.